Problem 96, Quantum Mechanics. The question is, a particle of charge q in one dimension is in a simple harmonic potential with angular frequency omega. It is subjected to a time-dependent electric field E of t is equal to a e raised to minus t by tau whole square, where a and tau are positive constant and omega tau much greater than 1. If in the distant past t tending to minus infinity, the particle was in its ground state, the probability that it will be in the first excited state as t tending to plus infinity is proportional to. Here, we have to find out the transition probability PIF. What is the initial state? It is given that it is the ground state, ket 0, and the final state is the first excited state, that is ket 1. Now in the transition probability equation, we have a term WFI, that is simply W10. What is W10? It is E1 minus E0 by H bar. E1 is the first excited state energy and E0 is the ground state energy. Therefore, E1 minus E0 by H bar is nothing but omega. That is WFI in the equation of transition probability is W10, that is nothing but W. Also, in the transition probability equation, we have a term V of t. This is nothing but the potential energy. We can calculate it using the equation minus integral QE dx. What is E? It is given that E is equal to a e raised to minus t by tau whole square. Therefore, the potential energy becomes minus q integral a e raised to minus t by tau whole square dx. Let us take the constant terms outside, then the integral become minus qa e raised to minus t square by tau square x. That is, the potential energy V of t is equal to minus qa e raised to minus t square by tau square x. Now let us find out the transition probability corresponding to a transition from the initial unperturbed state ket 0 to another unperturbed state ket 1. We can write the equation as 1 by h bar square, then modulus integral one V of t 0 e raised to I omega 10 t dt square. Now let us put the limit of integration. Then PIF become 1 by h bar square modulus integral minus infinity to infinity 1. What is V of t? It is minus qa e raised to minus t square by tau square x. Therefore, the quantity inside the bracket, inside the integral is 1 qa e raised to minus t square by tau square x 0 e raised to I omega t dt whole square. Now again let us take the constant term outside, then it will becomes q square a square by h bar square, the modulus integral minus infinity to infinity, then 1 e raised to minus t square by tau square x 0 e raised to I omega t dt, then square. This is equal to q square a square by h bar square modulus integral minus infinity to infinity 1x0 e raised to minus t square by tau square, then e raised to I omega t dt square. Now this is equal to q square a square by h bar square modulus. Now what is 1x0 in harmonic oscillator? That is root of h bar by 2m omega. Therefore within the modulus we have root of h bar by 2m omega, then integral minus infinity to infinity e raised to minus t square by tau square plus I omega t dt whole square. Now let us simplify the expression. PIF is equal to q square a square by h bar square, then h bar by 2m omega modulus integral minus infinity to infinity e raised to minus t square by tau square plus I omega t dt whole square. Now the integral is of the form integral minus infinity to infinity e raised to minus at square plus bt dt. Therefore PIF becomes q square a square by 2h bar m omega modulus. We can use the result of the standard integral root of pi by a e raised to b square by 4a, where a is equal to 1 by tau square and b is equal to I omega. Therefore our integration becomes root of pi tau square root of pi tau square, then e raised to minus omega square tau square divided by 4 whole square. Now this is equal to pi tau square q square a square divided by 2h bar m omega, then e raised to minus omega square tau square divided by 2. That is, we can say that the transition probability PIF is proportional to e raised to minus 1 by 2 then omega tau whole square. Therefore we can say from the given option, option A is the right option.